Welcome to another edition of RCE. This is Brock Palen. You can find us online, subscribe to the show, find the RSS feed, etc. at rce-cast.com. I also have with here Jeff Squyres, one of the authors of the newly released OpenMPI 1.6. So, Jeff, thanks a lot for your work on that, and thanks a lot for helping with this show.
Yeah, we're very pleased we finally hit that milestone. I think we said this in the podcast that we recorded yesterday as well, but, these things sometimes get mixed up in actual publishing order, so we'll see who actually makes it out, whether you hear this announcement 3 weeks from now or very soon. But, hey, one other thing I wanted to plug real quick, too, is that just recently I had a book chapter published about the internals of OpenMPI, more specifically the overall architecture of OpenMPI. It's in a book called Open Source Applications, The Architecture of Open Source Applications, Volume 2. And actually, all the proceeds from that book are going to charity. They're going to Amnesty International, so not even getting a dime for that. And I'm just one chapter of, I think, 25 or 26 chapters. There's a lot of other well-known open source applications in there that it's fascinating to read about how those things are architected, like the Hadoop file system and Git and Firefox and some other things like that. So it's a good book and it's a good cause, and go buy it. You'll do a little good in the world, and you'll learn a little something too.
So our guest today, though, we have a repeat guest, which is a very exclusive club. Getting to be stuck on the phone with us twice. Yeah. Is Doug Smith from Colorado and Péter Molnár. They are going to be talking to us about this year's student cluster competition. This is a great opportunity for students, so if you have students who are interested in HPC, this is something you should pay close attention to. So, Doug and Péter, why don't you go ahead and take a moment to introduce yourselves?
Well, like I said, my name is Doug Smith. I'm with the Laboratory for Atmospheric and Space Physics at the University of Colorado. I am their network and HPC architect.
I'm Péter Molnár. I'm associate professor at Clark Atlanta University.
Okay, so before we go too far into anything, what is the student cluster competition?
So the competition is for undergraduates. It gives a group of undergraduates an opportunity to build a high-performance cluster on a limited power budget of 30 amps and basically run a small high-performance computing center in a 10x10 booth at the conference. It runs 24/7 for about 48 hours. And they get to run a lot of scientific applications that get used in day-to-day science.
All right, so this is at the supercomputing conference, right?
Yeah, this year it'll be held in Salt Lake City in November, and it'll be the conference is the November 10th through the 16th.
Okay, and when does the actual cluster competition run during that conference? It's only a couple of days in there, right?
Yeah, we'll actually we haven't nailed down the exact hour-by-hour schedule, but typically it runs Saturday through Thursday, and we have set up on Saturday and Sunday, and then we start the competition bright and early Monday morning and end it Wednesday afternoon.
All right, but there's months of prep before that, right? I mean, it's the actual competition is almost anticlimactic because it's 4 days of flurried activity, but there is a huge lead up going into that, right? Tell us a little bit about what teams do to prepare.
So currently, we are accepting proposals from teams all over the world who want to come and compete in this, and the teams will typically start, like I said, in the spring, partnering with vendors, putting hardware together, compiling the applications, and sort of benchmarking their clusters. Many of the students, since this is an undergraduate competition, don't have any experience in this specific area of computing, so they're entering a steep learning curve starting in the spring and culminating in November.
One of the challenges is for the teams is to identify vendors and then come up with a solution. So we have set out a set of scientific applications, and the students and their vendor partner need to identify how to build a system that would be most suitable for these kind of applications, such as using GPUs or using many cores. And then again, the cluster that they run needs to be within that 26 amps power budget.
So you mentioned in the spring, though. I mean, we're in May right now. Can new teams apply right now? If someone hears this show tomorrow, will they be able to still try to participate in this year?
Oh, sure.
So what are the deadlines?
So the proposal deadline is May 27th. So you have to have your proposal in before that day, and then we will be notifying teams towards the end of the month, like the 31st.
One of the things that is new this year is a pilot program that is based on a different type of hardware, the little fee systems. And this is an educational cluster designed for educational purposes. And teams might be still, if they have some experience in high-performance computing, might be able to organize and apply for that track if they have not been participating in the student cluster competition prior to this year.
No, wait a minute. So I've been a judge for this competition before, and Jeff has also. When you're talking the little iron systems, those like a couple motherboards in a box, that's something new. Can you elaborate on that?
Yes, the idea actually started from considering whether it would be possible to have a competition like this, a similar competition on a much smaller budget, meaning that instead of trying to find a hardware vendor, which there are only just that many, if teams could just buy for a couple of $1,000s, a couple of $100s, buy components and build a small-scale high-performance computer which could basically perform the same type of computation or use the same applications and kind of replicate the same experience that the standard or big iron cluster competition has, just on a smaller scale, which would maybe allow us to create regional competitions. And
interesting. So do they have different metrics that they're judged on, or are the requirements different over there? So like the canonical 30 amps requirement is the one that we talk about all the time for the big iron one. Is there a different power requirement, or do they run different apps on the little one?
Well, that's actually something that we need to work out. And it's basically what we did for this year. What we're planning is to have a pilot competition. 4 teams will be invited to use the little fee system that was developed at Earlham College. And so we're actually going to provide them with the same hardware. There's still a lot of factors that they need to, if they understand the system, that they can tweak on to be competitive. But the vision is for this type of competition to broaden that hardware requirement. And I think one of the things, it's easier with the big iron to say, okay, we do a limit on 26 amps, which is basically power supply that goes into one rack. For a smaller scale application, that is kind of has to be developed. And we hope with leading up to SC12 and then the results of the SC12 little fee competition, that we have a better idea how we could form this kind of competition and what kind of parameters we would set that would be similar to the ones that we have in the big iron competition.
So back to the traditional big iron competition, you keep mentioning this 26 amps, so they're limited by how much power they can draw. Like, how much power really is 26 amps?
Well, you couldn't run 3 coffee makers on it. If you look at household appliances, toasters and waffle irons and popcorn machines, you couldn't run more than 2 or 3 of those on 26 amps.
So they're really constrained here on how much power they can draw. What happens if like a team goes over? Like what happens in that case?
They'll be penalized or disqualified depending upon the nature of the of how badly they went over. We've never had anybody disqualified. Usually we begin to see a team breaking that 26 amp barrier. We go down and politely inform them that they're over the limit, and they make adjustments. Usually on Saturday and Sunday, there's enough time to test the clusters out that the students get a pretty good feel for what the rule limitations are. And we always encourage questions. So.
Now, power is one metric we've been talking about here. What are some of the other metrics that they're judged on for, what kind of applications do they run, and, how do you determine who the winner is?
So in the standard track, usually we have a couple of different awards. We have a highest LINPACK award, which obviously is the highest LINPACK numbers, the highest sustained computational rate. And we judge that basically the same way they judge it in the top 500 supercomputer list by your highest HPL LINPACK results. Then we have an overall winner, which is taking into consideration the LINPACK numbers as well as how much of the computational load you're able to get through in the 48-hour time span. Those two metrics together with an interview portion at the end, usually we combine all those scores, and that's how we come up with our winner. So it's interesting to note that in the past, bringing the fastest hardware and producing the fastest LINPACK does not necessarily win you the overall.
So what have been some of the novel things that these student groups have done to kind of up their performance, to kind of give them an edge?
Cooling efficiency has been an issue in the past, right? We're running on room air, so there's no special cooling. So last year, the team from Texas brought a liquid cooling system and suspended their nodes in mineral oil, which worked quite well. In the past, we've had extremely high efficiency clusters like the PsiCortex, which was brought by a team in Austin a couple years ago, which was extremely low power usage and extremely high core count.
Do you see any other non-traditional things like, say, GPUs or accelerators or, strange CPU architectures?
Over the past 2 years, GPUs have crept in and played an increasing role in the competition. 2 years ago, we might have had one team bring a GPU. Over the past 2 years, we've seen 2, 3, 4 teams include GPUs in one or two of their nodes. And it's a balancing act. Not all of the applications get a significant increase in performance from GPUs. Some of them don't even run at all on GPUs. So you have to balance what you can do with GPUs and the power hit that is incurred by using that technology with your throughput and the applications and the traditional CPU core architectures.
So on the CPU side of things, do you typically see the latest generation of Intel or AMD chips every year? Like this year, do we expect to see some Sandy or Ivy Bridge? Or do you actually tend to see, larger numbers of less powerful chips, for example? Like you mentioned PsiCortex for one.
Right. In the past, we've seen sort of a smattering of both, the latest and greatest technology versus technology that may be 1 or even 2 years older, but that is tried and true. And sometimes you'll see teams bring the latest and greatest fast CPU, and in the same competition, you'll see a team bring a lot of very low voltage model CPUs that maybe don't have the highest clock rate, but they can get more of them in under the power budget. We've seen teams take both approaches.
Now, are teams allowed to switch hardware in the middle, like bring a bunch of hardware and then power on some things and power down other things as long as they stay under 26 during the run of the contest?
So the teams are limited in that whatever hardware they run their LinPack is the hardware that they are set with for the remainder of the competition. So if you bring 8 nodes of whatever architecture, and that's what you run your LinPack with, and you're under the power budget, then your configuration is effectively frozen at those 8 nodes for the rest of the competition. You can reboot them, but they all have to be powered up. That configuration has to be powered up for the remainder of the competition. You could not, for instance, bring 10 nodes and leave 2 nodes powered down and run on 8 for the LinPack, and then fire up the other 2 for the applications. LinPack is particularly power hungry, so most teams bump the power curve when they're running LinPack. So it's quite possible that when you get into the application phase of the competition, your power draw is not quite as high, and you may have some budget there, some power budget there for another node, but you can't add it because you're sort of set on your configuration at that point.
So we were talking about some of the hardware trends there. What has been some of the performance trends? I mean, we've kind of, for a couple of years, had this fixed power. What has the actual performance and scores looked like over the last few years?
So 6 years ago at the first competition, the winner of the LinPack was Taiwan. It was a team from Taiwan, and they posted 420 gigaflops as the highest LinPack. Last year, I believe a GPU-enhanced cluster from Russia posted 1.9, nearly 1.9 teraflops. So that gives you an idea of how far we've come in just 5 or 6 years.
And that's with the same 26 amp budget, right?
Yep, cool. Same power limitation.
Cool. So what software does gets used here? Are there? I mean, I think that you give them specific apps, but then like which middleware and which operating system, all the rest of that is up to the students, right?
Correct. The teams are free to use whatever software stack they feel comfortable with. Obviously, it has to be able to run the models and has to be able to produce accurate results. But they're free to use any software platform. The majority of them over the years have been some kind of Linux-based software stack with various tools like OpenMPI and GNU compilers, Intel compilers, PGI compilers.
So then are they given like a collection of runs, and each of those, if they finish a problem and the problem validates, do they get points for it? What happens if they're like halfway through a run and they have a checkpoint or something like that? Can they get like partial credit?
So typically we have 4 or 5 applications. They're modern day research apps. And for each app, we will provide a series of data sets. And the data sets can be very simple to very complex. Some data sets you may not even be capable of running on a cluster that will run on 26 amps. So the idea is that the students have from now, today, until November 12th, to optimize the apps, compile them, learn how they behave, profile them, whatever. And then we're going to give them a series of mystery data sets. And they'll have to sift through those data sets and figure out which ones they can run. At this point at the competition, it becomes resource management. What jobs can I run? What jobs can I not run? How can I estimate how long these jobs will run? So the basic judging is whoever gets the furthest through the workload, the total workload, accumulates the most points. And there are points per data set that are allocated.
All right, so basically, one approach that I saw with a couple of teams is that they would designate individual members on their teams to become subject matter experts in particular types of applications. I'm sorry, in particular applications, because you publish the list of applications, not the data sets ahead of time. So this year, have you published the applications yet?
Yes, we have.
What are they?
There's LAMPS, which is a molecular dynamics. There's another quantum dynamics, QMC pack. There's a climate model called CAM. And then there's a reactive flow modeling called pFlowTran. And then they'll also be expected to run the HPCC suite of benchmarks, which includes HPL.
So from my own experience, I know these students are scored on things besides just running their applications and staying under 26 amps. What are some of the other things that the teams are scored on and go towards the overall winner?
So the teams will be interviewed by a set of experts. So there's a portion of their score that is determined by the interview process. And in the interview process, usually we like to see that the students have visualized the data from the models. And that also gives the students an opportunity to sort of show off what they've learned in the process of being in this competition.
So if I'm a student or a faculty advisor listening to this podcast right now, and this sounds like something that's interesting to me, what is required from a logistics point of view, from an organization point of view, right? So I just said there's a faculty advisor needed, but what else do teams need to do, and what do they need to provide to be involved in the competition?
So Peter, you want to talk about Little Fee?
Yeah. Well, for the Little Fee competition, which is a pilot project, we actually have we're going to provide them with the hardware. So this year, because it's a pilot, we have hardware available for them. Of course, the teams should have some experience. So we particularly target institutions who already participated in some way, maybe the faculty member in some way in the Little Fee build-out or other activities. Students basically just have to prepare themselves. They need to understand how to install the software stack, how to operate, and also basic experiment with the scientific applications. Once they come on the site, they actually are going to they're going to get the hardware, the individual components in those 48 hours when the competition starts. And they have to put it together and then install everything and then run the scientific computation which is the downside of the standard competition. Other than that, they don't have to, they should at least get their hands on some equipment that is similar to the Little Fee. They don't have to bring their own system.
Oh, I was going to say, for the standard track, it's a team of 4 to 6 undergraduates, usually partnered with some kind of a sponsor or vendor. So a team might be partnered with a cluster manufacturer like IBM or Cray, or Dell for that matter, which will give them hardware to work with and provide some mentoring opportunities and advisement opportunities in their HPC community within their organization. And then it takes a whole lot of passion for this type of computing. Most of the students that I've had on my teams, this is the area of computing that they really wanted to get into. They are working on systems which are on the big iron track. These systems are extremely similar to what you would find in any large computational facility. So they like the idea that they're getting some hands-on experience with systems that are used in industry.
So you mentioned earlier that for the Little Fee project, I think you said you were accepting 4 teams for this year, and I know there was a limit, for the number of booths you had for the Big Iron competition. How many teams normally apply? How many do you accept? How many are you accepting this year?
So for the standard track, the Big Iron, we have 8 slots to fill. So we'll be inviting 8 teams. We've already exceeded that many proposals, and we're accepting more every day. I believe, Peter, correct me if I'm wrong, but there are 4 slots for the little fee.
That's correct. And the little fee teams are a little bit smaller. Right now we have only 5 people per team.
So, Doug, assumedly you're not coaching this year as you have done in the past. So, is Colorado stepping up? Is someone else taking your place to send a team this year?
Actually, I am taking a team to the ISC student competition in June. So I got asked to chair this, and it was a good opportunity and a good time for Colorado to take a break from the standard track and maybe mentor some other universities and encourage some other universities to submit teams.
So say instead I was a vendor, say I was a hardware provider like Dell and stuff, and say I didn't have a relationship with a specific school or a specific team, or I don't know if a school I have a relationship with has a team, can they contact you about getting paired with a team and sponsoring them?
Yes, they can contact us by sending an email to competition@info.supercomputing.org.
It's student-cluster.
Oh, sorry, yeah, student-cluster-competition. Sorry, in my browser it's broken up.
So you said you've gotten more than 8 applications already. How many have you gotten?
We have gotten to date 10 proposals for standard track and 2 for little fee. But we're still a week or so away, 10 days away from the closing date. Usually the last couple of days we see a lot of activity.
We have been in contact, so we encourage all the teams for both tracks to email us to the competition email address, student-cluster-competition@info.supercomputing.org. It's also posted on the SC12.supercomputing.org website. So we are already in contact with a number of teams which might not have submitted their proposal yet.
So what kind of things make a proposal stand out? I mean, I'm sure that some of this is closed door kind of discussions, but what makes a proposal look better than another proposal? What kind of criteria do you use to select who you're going to invite?
We like to see teams that have demonstrated the fact that they've already built the applications and can already put some performance figures in their proposal. They've already run LinPack. They already know, they already have a vendor partner, and they already sort of know their hardware architecture. The process usually, we accept the proposals in the spring, and we notify 8 teams, and then those 8 teams have to submit a detailed architecture proposal in September. So we like to see details in the proposal. Who my vendor is, what hardware I'm using, what software stack I'm using, and some kind of performance figures that indicate that they have already built the models and at least run the test cases.
We also like to see that the students have been engaged in some type of high-performance computing research project, and to include that in the proposal, what they're working on, what the experience is.
So once a team's accepted, what's some of the benefits of participation? Do you get in free? Do you get all the coffee you can drink? What's this kind of look like for the students?
For the students, this is an excellent networking opportunity for setting up. If you're a junior or senior, and you want to network in this industry to set up internships and potential career paths. They also get, all the Mountain Dew you can drink. They get sort of a backstage pass to seeing how the supercomputing conference happens over a week-long period. In other words, they're going to start setting up their equipment and setting up their booth on Saturday, the exact same time as the exhibit floor is being built up, which is sort of interesting to see how you get so much computing hardware into a convention center and built up. They also have the students get the opportunity to attend the conference as a full technical attendee, so they can go and listen to the talks and the panel discussions, visit the exhibit floor, win swag from the vendors. They also get the opportunity to meet and mingle with students from other countries and from other teams and sort of build some relationships there. In the past, we've had teams from all over the world: Taiwan, China, Russia, Costa Rica. So this really is an international competition.
So speaking of all these things that they get to participate in and so on at the conference, what is a typical day in the life of those 4 or 5 days? What do the students do? How does it typically unfold? Do they sleep in the booth there, or do they actually get to go to their hotels, or is it just an action-packed time?
So from Saturday to Thursday, a typical experience would be the students get there on Saturday and Sunday, and they'll set up their clusters. They'll find out, what things that they forgot to bring, and they'll find out where the nearest Best Buy or Computer Shack place is to buy that VGA cable that they forgot. They'll find out what was broken in their cluster in shipping. So Saturday and Sunday is test and tune. They have access to their equipment 24/7. Monday morning, we usually start the benchmark, and by this time, a team of 4 to 6 students, usually they might have gotten 8 or maybe 10 hours of sleep from Saturday to Monday. The students like to stay there, and they've invested a lot of time by the time November rolls around in their clusters, and they're really trying to eke out every last operation per second that they can get. They'll start the benchmarking on Monday. They might get 3 or 4 hours of sleep here or there. Most of the time, a team will have boosted the nearby furniture from any kind of waiting area, and they'll be sleeping on the couches and under the tables, so that they can be there if something crashes or something goes wrong, or they'll be warming themselves by the exhaust of the clusters and drinking massive amounts of Mountain Dew or whatever their soda of choice is. Then about Wednesday afternoon, we'll stop the competition and we'll go out as a group and have some kind of a nice dinner as a group so they can mingle and sort of wind down. And then usually
probably their first solid nutrition of the week.
Yeah. Then they'll be back for the final judging and announcement of the winner during the awards at SC on Thursday. Thursday morning, they usually get to show off any kind of pet projects that they've been working on. If they've been working on their own applications or doing out-of-the-box things with the science applications that we've given them. Thursday mornings usually show-off time, any kind of visualizations, things like that.
Okay, so I'm a student. I'm strung out on caffeine, but it's all worth it. I've won the competition. What's all the glory?
The glory is typically some kind of plaque and then bragging rights. It's there's no fame and fortune outside of the HPC community, but they're really big bragging rights, and the winning team usually gets an automatic invite if they to the next year's competition. So you have to defend if you win, and everybody is sort of gunning for you.
Okay, guys. Well, thank you very much for your time. This is a great project. I really enjoy talking to you students. It's amazing some of the ideas they come up with to stay inside those power envelopes. The Little Iron project, Peter, that sounds like a nifty thing. I like the idea of getting more opportunities for more students, because I know every year we end up not accepting everybody who applies, and we'd love to be able to if we could. But again, thank you, and can you again remind us the deadline and where they can find information to apply?
The deadline for proposals is May 27th, and they can get more information at SC12.supercomputing.org. And we're under the Communities, Student Programs, Student Cluster Competition.
Okay, guys, thank you very much.
Thanks, guys.
Thanks. Yep, thank you.